Hi everyone. Today I want to discuss about bond line drawings in organic molecules. These organic molecules can be drawn in many ways. One is Lewis structure, or it is also known as complete structure. The second one is known as condensed structure. The third one is known as bond line structure or bond line drawing. Lewis structure, condensed structure, and bond line structure. Now, how to read bond line drawing? In bond line notation, all carbon atoms are connected to each other, known as a backbone to that molecule, and these are represented for a straight line or maybe cyclic structure in the zigzag manner. In this structure, we are only representing the backbone of the organic molecule but not represented the carbon and hydrogen atoms. In bond line notation, double bonds are shown with the two lines and triple bonds are shown with the three lines. Now in this given structure, this is a double bond and this is called a triple bond in a structure. In bond line notation, in triple bond representation, a small gap is may acceptable. That is, this structure can be represented like this. It is acceptable. Reason in this is called a triple bond between the carbon and carbon atom. So this is the same as this compound. So this compound has a 6 carbon atom. 1, 2, 3, 4, 5, 6. So here also 1, 2, 3, 4, 5, 6 carbon atoms are present. The two carbon atoms of triple bond and two carbon connected to them are drawn in a straight line. All other bonds are drawn as zigzag. Keep in mind in this structure, triple bond drawn as a linear structure because this triple bond sp hybridization and with 180-degree angle. Therefore, this will be represented as a linear. Remaining bonds are represented as a zigzag manner. No problem, but compulsory keep in mind when you draw a bond line notation that should be a triple bond linear structure drawn. Now the given example is this is a triple bond. A small gap is acceptable, that indicating the triple bond. Now keep in mind this is 1, 2, 3, 4, 5, 6 atom. This is same as 1, 2, 3, 4, 5, 6. Generally many of the students will do mistake in drawing the triple bonded organic molecule. So now very clearly I am telling that triple bond should be linear like this linear structure, or a small gap may also maintain, that is acceptable in bond line notation. For example, here given one compound 1, 2, 3, 4. So this is called butane. This butane can be represented as drawn like this 1, 2, 3, 4 carbon atoms. This is called butane in bond line notation or representation. But this molecule 1, 2, 3, 4 carbon atom is drawn like this because here 1, 2, 3, 4 carbon atom. So triple bonded carbon atoms are drawn in a linear. So now they may ask the question, in this molecule how many carbon atoms are in linear? Mean 1, 2, 3, 4 carbon atoms are in linear position. because now this is compulsory in a straight line format, therefore all four are in linear, but hybridation is different, that is called, these are sp3 hybridation, but these are which one, sp hybridized carbon atoms. For understanding purpose, one question for you. Count the number of carbon atom in each of the following drawings. So here given one is a benzene and this is another compound 1, 2, 3, 4, 5. Second position keto group is there. Then it is called pentane 2O. Like this compound I mentioned here. Then you have to count the number of carbon atoms. For this benzene compound, now I am counting the number of carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms. For next compound is 1, 2, 3, 4, 5 carbon atoms. This is the way of counting the number of carbon atom in bond line notation. Now, the question is count the number of carbon atom in each of the following drawings. So, in this given compound, we have to count the number of carbon atoms. 1, 2, 3, 4 molecules are given here. Now, in this given compound is number of carbon atom 1, 2, 3, 4, 5, 6 carbon atom. Then answer is 6. Next one 1, 2, 3, 4, 5, 6. Then here also we have 6. Next one 1, 2, 3, 4, 5. Then we have 5. Next compound is 1, 2, 3, 4, 5, 6. Then we have 6 carbon atoms. Now we know that how to count the number of carbon atom in bond line drawing. Now we should learn how to count the number of hydrogen atom in bond line representation or notation. In bond line representation, most of the hydrogen atoms are not shown. It means we are not drawing. So bond line drawing can be drawn very quickly. In hydrogen atoms are connected to atoms other than carbon. So keep in mind, generally when you draw a bond line structure, carbon and hydrogen atoms are not shown, but we have to show the hydrogen atom which are connected to a heteroatom. Heteroatom meaning what is that? The atom other than carbon and hydrogen. So keep in mind, hydrogens are must shown, they are connected to heteroatom, like nitrogen, oxygen, sulfur, they are called heteroatom. When they bonded to heteroatom, that hydrogen atom must be shown. For that, one example, here given compound is, in this nitrogen, there is a heteroatom hydrogen bonded, that is shown in the bond line notation. Here this is a secondary amine. In this compound is alcohol. So hydrogen is bonded to oxygen, that atom must be shown, that's represented here. This is thioalcohol compound. In this sulfur is a heteroatom. So hydrogen bonded to sulfur, that also shown in the molecule. Keep in mind, carbon and hydrogen are not shown in the bond line notation when it is hydrocarbon only. If the any other heteroatoms are present in a molecule, hydrogen must be shown. Generally in bond line notation, one of the example I took here, this is a shown with a dark color. Now, uncharged carbon atom have total 4 bonds. We know that carbon valency 4, it forms the 4 bond. Now here given this specified atom. Now according to bond line notation, it has 1 and 2. 2 bonds are present. This is 1, this is a 2. So carbon valence is how much? 4. But we drawn how many bonds now here? 2 only. It means remaining 2 bonds are which one? They are bonded with the hydrogen. So we only see the two bonds in the structure connected to the this carbon atom, but remaining are which one? They are hydrogen atom. So keep in mind, a neutral carbon atom in bond line notation has a 4 bond. If charge species are there, then it depends upon the positive and negative charge. Anyway, carbocation when positively charged, it has a 3 bond. Carbanion also, it has a lone pair negative charge with the 3 bonds, but neutrally it has a 4 bonds. Keep in mind, based on that only we have to draw the bond line structure. Otherwise, if you are drawing more than one extra bond, that is 5 bond, mean that is not acceptable. Now I am giving one question. The following molecule has 9 carbon atoms. Count the number of hydrogen atoms connected to each carbon atom. Now I shown with the dots. These are the carbon atoms: 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. So we know that a neutral carbon atom has a 4 bonds around it. So now I can show here for your clear understanding purpose. This carbon has one bond, one hydrogen, second hydrogen, third hydrogen. These are having which one? Hydrogens. Like this, I clearly shows in another a clear representation. So keep in mind that terminal carbon having the 3 hydrogen. In the carbon which is present in between the other carbon atom, it may be having 1 or 2 or maybe depends upon the its valency. That I will show you in the form of one clear representation. Now here given molecule, the this one left to right I am clockwise calculating the number of hydrogen, because already we know the number of carbon atoms. So this carbon atom has one bond, therefore remaining are 3 hydrogens. Next one, this carbon also has one bond, therefore 3 hydrogens. Next, this arrow mark shows me this carbon. We know that this is a triple bond. So around this 1, 2, 3, and this one 4 bonds are there. Therefore, no hydrogen. This carbon atom also has 1, 2, 3, and 4 bonds. Therefore, no hydrogen. Now this carbon atom has 1, 2 bond. Therefore, remaining are 2 hydrogens. Next one, the last one carbon has one bond, therefore 3 hydrogens. Now this carbon atom has 1, 2, 3, 4 bond, therefore no hydrogen. Next, this carbon atom has 1, 2, 3, 4, therefore 4 bond, no hydrogens. This carbon atom has 1, 2, 3, therefore 1 hydrogen. Like this, we have to count the number of carbon and hydrogen atom in any bond line notation. Now the question is, for each of the following molecules, count the number of hydrogen atom connected to each carbon atom. Now I am starting from this carbon. 1, 2, 3, 4. Then here no hydrogen. 1, 2, 3. Therefore here 1 hydrogen. 1, 2, 3. Then here 1 hydrogen. 1, 2. Here 1 hydrogen. 2 hydrogen, because carbon valence is 4. 1, 2. Then here 2 hydrogen. 1, 2. Then here 2 hydrogen. Overall, total hydrogens are 1, 2, 3, 4, 5, 6, 7, 8. Total 8 hydrogen atoms are present here. Hydrogens are 8 and carbons are 6. Now here I shown the all hydrogen atoms and carbon atoms. Like this remaining molecule also we have to calculate. One more example I will show here. Now in this second molecule we have 1, 2, 3, 4, 5, 6, 7, carbon atoms. Therefore, carbon is equal to 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 hydrogen atoms. Like this, we have to calculate for the remaining molecule also. Generally, we can utilize this bond line representation in the chemical reaction also for easy to understand where the reaction takes place. This is called a condensed reaction. This is called bond line representation, where this double bond is there, that is reduced by this hydrogen and platinum catalyst. So here also this double bond is reduced and C double bond will remain. So in chemical reaction also we can utilize this bond line representation. After knowing all these, counting the number of carbon atom, counting the number of hydrogen, then how to draw a bond line drawing. For example, here mention this is one molecule. In this we have carbon atom, hydrogen atom and hetero atom like oxygen also present. So in drawing the bond line structure, keep in mind we have to draw a carbon skeleton and a heteroatom which are present in the molecule. The first one, don't forget the carbon atom in a straight chain are drawn in zigzag format. Now this you consider 1, 2, 3, 4, 5. These are drawn in the zigzag manner. Keep in mind carbon atom which are in a straight chain that should be drawn in the zigzag format. Second one rule is when drawing double bonds, try to draw the other bond as far away from the double bond as possible. Simply keep in mind from the double bond, other bond should be drawn as possible as far away from the double bond. That is a better representation because in double bonded carbon having nearly sp2 hybridization in 120-degree angle. That you have to keep in mind. So according to the first rule, this is a straight chain carbon. This is drawn like this zigzag manner. So carbon which are in a straight line that should be drawn in the zigzag manner. According to the second rule, when we are drawing a double bond, try to draw far away from other bonds. For example, this is a double bond, these are the other single bond. This single bond should be draw away from this double bond. So this is a better representation. This is called a better representation. Then the another one, this is called a not better representation, this is called bad representation because this angle is very less between the bond. Therefore try to represent always far away to each other. Now the third rule is when drawing zigzags, it does not matter in which direction you are start drawing. For example, now I am drawing this one molecule 1, 2, 3, 4 like zigzag manner. It is the same as we can draw. This is from the now here drawn from bottom to top. Now I am drawing here top to bottom like this zigzag manner. This is a substitution. Now I can draw like this also 1, 2, 3 like this. Then all these are correct representation, all are same or we can call identical manner. From any one direction you start drawing this zigzag representation. So now I am giving one question for you. For each structure given below, draw the bond line drawing in the box provided. So this is a homework for you. After understanding all these given points, you have to draw the a bond line representation. For your understanding purpose, one I will draw and I will show you that. Here, given molecule 1, 2, 3 carbon in a straight line, 1, 2, 3 carbon in a straight line. This can be drawn as totally we have 3 carbon. So we have 1 and 2. Total number of carbon atoms are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a bond line representation. One more example for a better understanding. This is the oxygen atom 1, 2, 3, 4, and this is 5 and 6 carbon atoms are there. So in a chain 1, 2, 3, 4, and this in the ring a heteroatom is present. This can be drawn as oxygen atom, heteroatom must be drawn, and these are called 1, 2, 3, 4. This is CH3, this is a CH3. This is called a bond line representation. Remaining for your homework purpose I given this is, so you try to draw a structure for this given molecule. Mistake to avoid to draw a bond line structure. The first one, never draw a carbon atom with more than 4 bonds. This is a big no, no, no. It meaning you no need to draw the more than 4 bond. Compulsory you have to draw around the carbon atom only 4 bond. More than 4 bond is not acceptable. Now second mistake, when drawing this molecule, you should either show all the hydrogen and all the carbons or draw a bond line drawing where the carbons and hydrogens are not drawn. So totally what you understood from this one, draw, it means show all the carbon and hydrogen atom in a molecule, otherwise draw a bond line structure. When you draw a bond line structure, what you have to draw? A zigzag manner of this carbon straight chain and heteroatom. When hydrogen bonded to heteroatom, that must be shown. So you can't draw the carbons without also drawing the hydrogens. It meaning now I drawn this is the compound with the carbon without hydrogen. It means you can't draw the carbon without also drawing the hydrogen. It means this representation only with the carbon without hydrogen. So when bond line notation meaning what is that? No hydrogen, no carbon, only bonds are represented. But here carbons represented without hydrogen. This is a never do this type of representation. Keep in mind. You should show all carbon and all hydrogen. Otherwise only bond line notation. But don't show half of the only carbon or hydrogen. That is a wrong representation. This is called a bond line notation. This is called a complete Lewis structure. In this, only carbon skeleton with the bond represented. Here, carbon and hydrogen, all carbon, all hydrogen atoms are shown. So, any one of the representation we have to draw, but in bond line notation only the bonds are represented, no carbon, no hydrogens are represented. Hydrogens are represented when the hydrogen bonded to heteroatom. The third mistake what we will do, when drawing each carbon atom in zigzag pattern, try to draw all the bonds as far apart as possible. So always draw far away to each other, because in sp3 hybridized carbon the bond angle is 109.28 degree. So these are represented somewhat a proper distance between the bond. Now I am taking one example. This is one example. This is a better representation. This is called a better representation than this compound. So this is called wrong representation, because up to here correct is there. Now here this bond is angled very close to each other. Therefore this is called a wrong representation. this angle is very smaller than this angle. Therefore, this is called a better representation than this given structure because the bonds are very close in this molecule. Here bonds are far as possible as away. Therefore, try to, now I am giving the suggestion, the bonds are always far apart from each other than the very close. That is a better structure. This is a wrong, not wrong, but this is not a better representation. So overall conclusion, what you concluded from this video is, first, how to draw a bond line structure, meaning a whatever a continuous carbon chain is there, that is called a carbon skeleton, and which is drawn in the zigzag pattern. And if any hetero atoms are present, that must be represented. And another one, in bond line notation, carbon and hydrogens are not represented, but hydrogen atom represented when it is bonded to hetero atom. And what are the mistakes we will do when you draw the a bond line structure, that also I explain here. So keep in mind, never draw a carbon with the more than 4 bonds. And also you may try to draw the maybe bond line notation or a complete representation of the carbon and hydrogen representation, but don't draw only carbon atom without hydrogen. Another one, all these zigzag patterns should be, the bonds are very far away to each other, but don't draw very close. In case the double bond is present, that should be shown with the 2 lines, and triple bond is present with the 3 lines. But 3 lines meaning that is sp hybridization, that should be shown as a linear pattern, and double bond you can write in the zigzag pattern. But if a carbon having double bonded with the oxygen or maybe nitrogen, that should also again represented as far as possible. This is a conclusion we drawn from this representation. From this we can count the number of carbon atom, number of hetero atom, number of hydrogen atom also we can count.